look like a mess, but we're going to roll with it. All right. Hi, everyone. I just sneezed and half died, so needed to handle that. But how's it going? It's very, very early in the morning for me. Much earlier than I'm used to streaming. But I took most of today off work so we could kind of work on this a little bit. Just because I think it's important, so. I'll go ahead and drop the link to the repo in the chat, just so folks can have access to it. Oh wow, we're already at 10 stars. That's impressive. A little fair warning, this is already released on HiPi, but it doesn't actually do anything. I just mostly did it so I could have the namespace of nbagile in case anyone decided to snipe that. So, mostly waiting for a few particular individuals to come, but that's all right. We can get started. So basically, the last time that we sort of streamed this, we wanted to turn document style code here. I'll go ahead and restart my kernel. Document style code here into NumPy style documentation code here. And before we were trying to use like a little bit of abstract syntax trees, AST, to sort of splice it and understand it. And we got a little far with that. We really did. And so I started working on it a little bit more. And that turned into this big old function. Now, basically what this big old function does is we take in the documents of a source, so the documents, right, the doc comments, like we're kind of designing for, the parsed syntax tree, and this get annotations function. And then we essentially do many things with it. So one of the things I could hack is I can read in the parsed annotation the arguments, grab its annotation, and just set it to none. And so what that does is, say we have something like addition a int b float, right? So I'll say, we'll do something like this, just for demonstration purposes, because everything is run on string representations of functions, right? So I can do AST parse O, which gives me an AST. Then I can do body at 0, which you can see is a function definition. And then if I do args.args, you can see that I have my two arguments here. So it has A and B. If I grab one of them, you can probably guess annotation is going to give me a name. And if I check the name of this, it's not name, it's S. point I remembered what this was. I think it's ID. Yeah. You can see that it's saying it's an integer. And so if I use a particular library called astunparse that undoes this, yeah. So that we basically get back, you know, what we should, right? I'll go ahead and print this out. That's not what I wanted. That way it's pretty for us. But if I set this annotation to none for both the first and the second variables, hey Saeem, how are you? If I set their annotations to none, when we go and unparse it, oh, that's because it's P. We have a clean parameter string. So it got rid of the types. But it does even... How chai am I on a scale of 1 to 10? Fairly chai right now, because I'm still like halfway through waking up. We can get even more crazy with this though, because let's say I write it in document style, right? So we have something like this, the first number to add, the second number to add. Right, this is our basic tutorial example of documents. Parse it. Reset the annotation to none. It still shows our addition AB. So it got rid of all of this and the type annotation, which is clean. That's similar to how Black formats things. So, taking that we can automatically do this now, that's how essentially the entirety of this project, of this section of the project, is built on. So let's delete instead of adding and look at this reformat function. Basically what this is designed to do is take in our source code as defined in documents. So if we got rid of, for example, all of this, you'd see that it's just a document style function. So we have addition AB, first number, B, second number, and then our output with its output documentation, right? And then an inner function, because I wanted to make sure it worked for inner functions, and a doc string. Well, currently, actually, oh, wait, that's why. There we go. There it is. We keep our defaults. We have our giant doc string with parameters, the type, and the documentation, the returns, the type, the documentation. Hi, so we're working on nbagile, and currently we're working on, well, I'm explaining a function that takes in source code that's formatted as document style. So it's this style of annotation where it's kind of similar to how you would document, say, like JavaScript, where you have the variable name and then each of the documentation for each variable is sort of on the side or right above it. And then converting that into your more standard like NumPy documentation string, such as this, automatically. And so what this allows you to do is be efficient when coding, but not have to like stress over writing things twice and everything. So there's that, and it's fully working, except there's one thing I need to do. Thank you. Yeah, the one thing I want to change is usually when it comes to this documentation format, you have the triple quotes and adds is on the first line of it as well. And I want to see if we can fix that. New line, get white space, 3 lines. And then it's whenever we adjust docstring. Okay, and we can do something like enumerate. Thanks for the sub. Also, we now have actual emotes. So it's all Batman themed because Batman. If I equals 0. Basically, we're putting an exception here that says if I is 0, we want the docstring to not contain a new line. And we'll do something similar. Actually, that should be all we need. Nope, it's not. Okay. All right, now I think that's what that is. I don't like how I'm repeating logic, but that's fine. We can clean the code later. Yep. If I equals 0. Oh, yeah, because we don't actually want get white space to be called. We just want line.strip. Cool. That's a PEP8 standard documentation string from something that is the very morbidly explicit not version of PEP8, which is the goal. So now I can like rewrite any source code that I want and have it follow PEP8 standards for function definitions specifically, which is about as far as we got in the last stream. I also have it work for classes now because I kind of went on a wild hair yesterday. So basically what you need to know for this is, so we parse everything through abstract syntax trees, which is how we grab everything. But what if you have like function in a function that has definitions? Like how would you deal with that? And the way that you do that is through recursion. So for those that aren't familiar, recursion is basically when I have like a function that calls itself up to a particular point and then rebuilds itself from that. So here, like, let's say I have a class in a class with functions and functions and classes. I can traverse from like the class to the class to the function to the function to the class, get all the information I need, rebuild it, bring it back, and then build it from that. And that is the very scary and intimidating thing that I had to do. And so like basically here I can check, okay, if we have a class definition, then because I can't just simply steal the code from the parsed and unparsed really source code, because, you know, as I sort of mentioned at the beginning of the stream, when you do that, you lose all of this document style annotation. It literally is just seen as, rather than source string, source code or function, after it's parsed by the abstract syntax tree, my function looks like this, right? So we lose all the information we need. So I have to extract it beforehand. So the way that we do that is literally through string finding. So I get the starting line, split my code up, get the ending line, make sure that if there's any like leading spaces, we need to format that because it technically still compiles the code. So any sort of Python syntax errors is going to pop up. And then we basically just call the recursion. So we say, all right, I'm going to reformat this code and make sure that my recursion level is increased by 1 of whatever it currently was. The recursion level is so we can make sure, like, okay, well, we got rid of the num leadings here. When we go back, we can still have them. Function definition here, we call that reformat function by extracting the source code. Otherwise, we just kind of do it. And then in this case, I want to say this is the doc string. And if it's not the doc string, then we just grab the raw source code. Now, what does this look in practice? This is the most extreme example that I can think of. So we have an arithmetic class, which is a class that can perform very basic, arithmetic is spelled wrong there. Arithmetic operations, right? We have 3 variables defined in it, lowercase o, lowercase b, or underscore o, underscore b, underscore c. We have an inner class A that doesn't really do anything. It's simply for the sake of making sure that my formatting works. So we have, like, this document style annotation for O in self.o. And then we have a proper constructor. And then we have a decorator function, right? So we have a function that has a decorator in it. And so these are, I want to write my own deep learning library from scratch. How do you recommend doing the same? I was thinking of going through FastAI part 2 of the course. Views on the same. Give me one moment to finish this thought, and then I'll answer that. So basically here I have to deal with the fact of this is that recursion. So like I have a class in a class with a function, and I have functions in a class. And the other thing is with NumPy style documentation strings, for the inputs, you don't deal with self. So I need a way to also make sure if self is there, which I think I'm currently doing. Yeah, I am. And here it is. Bar the fact that this doesn't technically follow that NumPy style parameter string. Oh, interesting. That's also not being done. Let me really quickly sidetrack. I promise I'll answer your question. But I just want to see. Okay, I think I understand what's wrong there. We'll deal with that in a moment. All right, so Probably Sleeping asked, I want to write my own deep learning library from scratch. How do you recommend going about doing the same? I was thinking of going through FastAI as part 2 of the course. What are your views? I guess my question would be, what would you want your own deep learning library to achieve? Like, how would it be different than something like FastAI? How would it be different than PyTorch Lightning? First, and make sure you understand why you want it to be that way. Is your goal like to be a stronger software engineer along with machine learning? Or are you just wanting to make sure that you understand like all the concepts that goes into like a deep learning library, and so as a result, like touching everything that deep learning really is under the hood? Which, if it's the latter, do it. That's an excellent way to learn. And even if it's the former. But FastAI as part 2 of the course is definitely how you'd want to get there. That deep learning from the foundations. Yes, perfect. That is exactly the goal that I was hoping you had, because that is the best kind of goal. That is kind of what I'm doing here as well, because I'm now learning like nbdev completely. Okay, cool. So yeah, do part 2 of the course, and that way you understand like how PyTorch works under the hood, and you understand everything. So if random typing occurs, it's because my cat is walking across my keyboard. I was about to say, Max, do not hit the enter button, please, for the love of God. Yes, kitty. So yeah, I mean that's what I'd recommend. Do it, like 100%. There's nothing wrong with doing that. You're teaching yourself something, and you're investing in yourself, and that's what you should always be doing. Especially if it's something you want to learn. I don't learn really by reading or watching people do, not watching people do things, but like I don't learn through like reading or a course a whole lot. Heck, or even reading documentation half the time. I learn by doing. So like I kind of wish that I went live when I was doing all of this, but I wasn't really feeling up to it because I was literally just playing around with the AST parser and just seeing what would work. So build the library, do it. That way, you have something that's pretty cool because you built a library from scratch for doing deep learning, but then also because you learn so much by doing that. So 100% go for it. All right, now we need to fix this bug. Which I think I know why. It stems from the has decorator. Function innards. What do I call function innards? Oh, all right. All right, so we'll say we'll do something like this. That's fine. Well, no, because that should be catching it. Okay, somehow we managed to majorly break this. Yeah, we don't want to do that. That's bad. That's very bad. Oh, of course, absolutely. You know what? I'm going to go ahead and steal my reformat function from here. And we're going to start it from scratch again. We're going to be smart. All right, so we get rid of that. Yes, absolutely. Next, we're going to train GPT-3 to basically build this for me. Did that unbreak everything? Not quite. Wow, we're still breaking. Was this just always an issue? Wow, it was actually always an issue. Okay, cool. Because it shouldn't matter if that's type dispatch. We can say like at delegates. Yeah. Okay. Well, at least we have a way for us to break this. So now we have a way to break it. We have a way to fix it. All right. So let's think about why this is breaking. Let's take a peek in here. Wait, hang on. Because decorator list is separate. So it doesn't matter if we have a decorator. So we just simply need to say parse source body. Oh, shoot. Okay. Given how this works, I thought that because we had a decorator, body at 0 wouldn't contain the docstring, which pretty much always it contains docstring. But if I thought that if it had a decorator, it would be in body 1 essentially, but it doesn't. So this should be able to work. Oh, we're close. We're very close. That's almost a docstring. Okay, all right. Okay, we can work with this. This is good. This is very good. I think that's because I hard-coded 1 here. So what if we do unparse source? What if we do something like orig docstring equals unparser, or what is it? It's what if we do this? Oh, we're close. We are so close. Hang on. Okay, so it has to be replaced instead of a strip. If you guys have questions as to what I'm doing, that's perfectly okay, because I have not explained much. Basically what was happening is we weren't getting the docstring how we needed it to be, because I hard-coded 1 rather than actually pulling where the docstring was, which we checked here, so I should have just done that. And basically, I need to strip out any quotations that we have, so that's what this is doing. So now that we have this working, there's that working how it ooh, maybe not. Hang on. Better. I didn't like the double lines between them. All right, so that's one fix. And just to make sure, what I basically do over here, I have black on the right, and I just double check that everything is roughly the same. 21 lines of code simply because we put a space here. I'm not worried about that. Black is going to be part of the pipeline in my head. So anything, the goal is not to have it look exactly like black. Like black will still have work to do. But we're going to get as close to black as we possibly can. As a latecomer to the stream. So the goal for today is basically to wrap up the class rewriting annotation, because I've already got something that works for this, but I want to make sure it perfectly works. And then afterwards, the goal for the stream is to undo it. Because the goal with this pipeline is we can take our documents code and export it over. But then we also need to have the ability to take our NumPy documentation string and convert it over to documents, which is this. So currently we start here and we end here. And then I want to go the other way. I want to start here and end here. Because this version, you can't see my hand. This version is very fast for when you're coding, and it's efficient. But this way is clean and verbose when it comes to reading the actual source code. And so the basically first roadmap of nbagile, if we see here, is literally this doc string. And I kind of realized that we needed to not only do it when exporting, but we also need to convert it back for this one. We might as well do it now. So there's that fixed. Now if we look at classes, it works. You don't know how proud and cool I am of doing this, by the way. Like, I budgeted a month to get up to here in my head. I did not realize that we'd get there in 48 hours. So, oops. Oops tea. All right, let's clean everything up and send it to GitHub. Because basically then from here, once we have this done, technically I could even do it from here, is well, I guess we could. We basically need to hook it into nbdev. But I want to save that for later. I'm also probably planning on streaming for like about an hour, hour and a half, and then I'm going to use the gym. I'm going to go to the gym because I slept in today. And then I'll come back. And when I come back is probably when we will look at NB process, which is basically Jeremy's new version of nbdev he's writing, more or less. It's unreleased. I'll go ahead and throw it in the chat. It's an unreleased version of nbdev that's basically a way for you to just take the notebooks and convert them to scripts. And I pinged him asking like for his opinion on a few of these things, and also he was the one that sort of hinted at, along with Hamel Hussein, to look at abstract syntax trees and tokenizing. He recommended that we build this library off of NB process instead. So probably not this stream, but the following stream later today, we'll look at NB process. And if we have any questions as we go along through it that pop up, I'm going to get on a stream with Jeremy later. This will be on the FastDI Discord, though, potentially. Otherwise, I'll just be asking him questions. And I'll send him any questions you guys have that I can't answer for us to make sure that we all understand where his headspace is and the code that he wants to make. Because I code the way I code because I looked at how Jeremy codes, and I wanted to mimic it and mock it as best as I could to understand his thinking. So we're going to do a similar thing here. And I'm writing something. Hang on. Yes, that's why. Absolutely. All right, so awesome, sounds good. And then we'll say new string. And then we get rid of all of that. And then we say that's annoying. Oh, that's why, because I need that logic to be in the reformat class too. Because basically what we did right there is I realized we have a situation where I have this. Right, where we have just A and B without any annotations and a single documentation string, single line documentation string. And what I need to be able to do is convert that into something like this, but it's not quite working how I thought it would. I mean, yes, part of us could assume that we never run into this situation, but I want to assume we do. Because parameters shouldn't be a thing. Right? No, it is always a thing. We don't have to do that. We need to do that for the class. Okay. This was completely useless because we only need it in the class annotation. Because even if you don't specify the typing, I actually have it hard-coded to just say that it's any, because that's kind of what NumPy does. Hence the any. Okay, that makes me feel better. I know roughly what we're going for. What we need to do is function definition, docstring. I need to find docstring in here. Hang on. Still works. Cat wanted to see the roommate, and in doing so, I just completely, dropped my mic off my table. Thankfully, it was muted. Otherwise, you guys would have probably jumped out of your seats like I did. Okay, so basically, yeah, so since we can always document it as any, what we really need to do is modify the class string. All right, so here we say if we need that logic down here. So we need to do... First, let's see how that looks. I imagine this should break. But... the fact that it didn't have anything has me concerned. Why did it not? Probably because I didn't actually... Okay. Because you're not getting called. Oh, because it has that new line? Okay, cool, that's better. You can kind of see what I'm going for here. And NumPy, we basically it as a single line with triple quotes. But what we need to do is do something like this, I think, is the answer. And really we could do is it 2 or 1? Oh, there's no. Okay. Well, that actually makes my life a lot easier. Because I think I should be able to just do this. That's what we want. And there's an example of something where, excuse me, it didn't have anything. Yeah. I won't worry about it. That's fine. Okay, that looks like a pretty clean class. Overwrite. And we even cover classes and classes. So I think from here, I'm probably going to go to the gym for a bit. And then we'll come back later and I'll talk about NB process, which might be round 1. No, I'll try and make sure you're here, Hall Effect. All right, see you guys later.